All right, welcome everybody to today's online training, getting started with Kubernetes in Rancher. Really glad you all could join. We have a lot to go over, and we have about 90 minutes to do it. So we're just gonna dive right in, kind of give you an overview as people join the call, join the line about what we are going to cover today. And the main objective is a really solid technical introduction, introduction underlined and highlighted of Kubernetes using a Rancher 2.0. So we'll go over, Kubernetes concepts, workloads, getting a cluster up and running and all that good stuff. We do have slides to show you to help explain some of these concepts and ideas, but we really are going to focus on demoing. I mean, the majority will be hands-on. And so if you have questions, please put them in the chat. As soon as you think of it, starting now, we can start to get to them as we take breaks and pauses and really tailor this training, to what you all want to know. So we are going to try to keep it, at an intro level. And if there is a question that is like super outside the scope of that, then we might refer you to some other resources, but we'll really do our best to answer, every single question, get to every single question before our time is up. So just as a quick way of introduction, my name is Matthew Shear. I'm kind of like the community advocate for Rancher. And if you have additional questions or you need help finding a resource or something, please email me, message me on Slack, and I will try to get that sorted out for you. And our technician on the line is Dan Ramich, senior software engineer, and his GitHub is there, and he will be, taking us through the majority of the content and really the main backbone for the knowledge on this call today. So just a little bit more context. We hope that you have a basic understanding of Docker containers coming in and some basic orchestration. And if not, it's okay. You'll still get a lot out of this call. We might refer you to other intro Docker resources if you do have questions about it. But we will make some assumptions in the way that we present this material. So if you want to follow along with your own Rancher instance going, you can go up to the deploy button on the website, rancher.com, and you'll be taken to this quick start guide, and you should be able to get kind of a sandbox or a single node instance of Rancher going in just a couple minutes. And that might help you follow along with what we're showing. A couple other resources. This is all open source software we'll be showing. Community is super important. Lots of contributions, questions, and issues are raised, and questions are asked on our Slack and forums, so slack.rancher.io and forums.rancher.com. And you can get more help there. And by the way, all of this material is being recorded. You will get after this presentation, hopefully within the next 24 hours, the recording as well as the slides and the Q&A. So with all that out of the way, we can get into the material, and I am going to switch this over to Dan. Are you ready to go, sir?
Yes, I am.
Awesome. So let me make you the presenter.
Let's see. Is it working?
Yes, I can see your screen. You're good.
Awesome. All right. Welcome, everybody. So I'm going to be doing a bit of slides first, just to give you some background information. And then, as Matt said, we'll jump into a demo. So let's just start off here. My name is Dan, again, a senior software engineer here at Rancher. I've been working in Kubernetes for a couple of years now. So why Kubernetes? Kubernetes has been growing a lot very quickly, which is probably why you're here currently. Rancher previously had a product called Rancher 1.0. In that one, we actually worked with other orchestration systems. So we worked with Docker Swarm, we had our own. And with 2.0, we realized that Kubernetes was getting bigger and bigger and was basically just taking over. So we switched. We are now focused solely on Kubernetes. It's huge. It supports many different design patterns. It's just getting bigger and bigger, and lots of big companies use it. Even if companies don't say they do, they're probably using it or experimenting with it. Let's take a look. So these are different companies that contribute to Kubernetes. It's not just Google. It's a lot of other companies. A lot of people have interest in Kubernetes, making it grow. So one of the downsides to Kubernetes, though, is it is huge, it is complex, and there are so many different ways to do things. How do I do authentication in it? How can I do it efficiently? So some of Rancher's goals is to make that easier. So use Kubernetes objects, use Kubernetes resources to make some of this stuff easier for you. So one of the other problems is because it does change so fast, that can make it hard to kind of keep up with what Kubernetes is doing. So again, Rancher can help with that because we do keep up with the latest versions of Kubernetes. Some of the interesting things with Kubernetes is how often they release. So even though they're doing minor releases, and they do technically follow SymVar, they can break in between releases. So just because you're going from 1.8 to 1.9 doesn't mean they didn't add a new API, change an API, delete an API. So trying to keep up with that can be painful. So it is a good idea to have some help, which is what Rancher can do. One of the downsides to Kubernetes is there's a pretty steep learning curve. So there are so many different resources out there. There's so many different objects, and it's not always easy to dive into Kubernetes. Like, where do you start? How do you create a cluster? One of the downsides is Docker knowledge doesn't exactly translate directly over to Kubernetes. So just because you can run Kubernetes doesn't mean that it's going to be easy. So what about Rancher and Kubernetes? So we give you a nice UI on top of Kubernetes. It's easy to use, and you can use it to configure, deploy, set up auth, a bunch of different things, which I'll show you later. It also gives you infrastructure management across multiple clusters and clouds. So it gives you a single pane to multiple clusters, which a lot of other things don't do. Automated deployment for the latest releases. As I said, we do keep up with the latest case versions. We're going to give you workload, RBAC, policy, and project management. Project is a Rancher construct, which we will talk about in a little bit. So we also offer 24/7 enterprise-grade support. So everything that I'm going to show you today is open source and free to use. But if you want support, we do offer support for that. So we do run on top of pretty much anything you can think of. So bare metal, any of the IaaS services, any cloud providers. So this is a general overview of how Rancher kind of works. So up at the top, we have application management. So this is just going to give you your UI, the CLI, different pieces for interacting with Rancher directly. After that, we have kind of a Kubernetes management plane, and that's going to go out and talk to your different clusters, your different providers. So down on the third layer, we have different places you can just straight run Kubernetes. So like EKS, GKE, and then down below we have your IaaS or your bare metal. So again, Rancher will run pretty much anywhere with pretty much any Kubernetes cluster. If you can get Kubernetes spun up, we can work with it. Here is a quick overview of how Rancher works. So the big square in the middle is the Rancher server. That's what you're going to spin up and run. If you take a note, there is an etcd storage. That is the same etcd that runs in Kubernetes. So if you back up etcd, you are backing up Rancher. If you wipe etcd, you wipe Rancher. But again, looking at this picture, you can see that we talk to different clusters. So down at the bottom right, we have GKE nodes. And then to the left of that, we have some RKE nodes. RKE is a Rancher product that allows spinning up Kubernetes very quickly. If you're looking to just spin up a cluster by itself, RKE is very useful. If you just create, say, a droplet on DigitalOcean, grab RKE, you can have a cluster up and running in a couple of minutes. So we are going to go through these 5 Kubernetes resources. There are a lot. There's a lot more different resources, but these are going to be kind of the building blocks of Kubernetes knowledge. So let's start with pods. Pod is basically the smallest unit that can be deployed in Kubernetes. It can consist of one or more containers that are always ran together. So containers inside of a pod are always spun up together. You can't spin up and down the container in the pod. Each pod does have a unique IP address, and then containers in a pod can speak to each other via localhost. So similar to running two services on your laptop, you can talk to it over localhost. The same thing happens when you're running two services in a pod. They do share essentially the same PID. However, they can be a little confusing because you can run multiple containers. A lot of times they are a single container. Sometimes they are multiple containers. When you talk about other services, some services will inject what is called a sidecar. So say you have a single container inside of a pod, you can inject a second container, which is referred to as a sidecar. For the majority of this, just kind of think as pods and containers as a single thing, and that'll make it a little bit easier going forward. This is a general overview of just kind of a two container pod. So if you're not familiar, on the left we have Nginx, and on the right we have a Redis, and they can talk to each other over localhost on Redis's default port 6379. So this is similar to being able to run it on your laptop. So you're running Nginx, you're running Redis, you just localhost to that port, and they're talking to each other. So this is nice because it does make it easier to run multiple containers in the same pod, and you know that your networking is just going to be easy to use. Designing Distributed Systems. This is a very good book. It talks about many different design patterns that we see in like Kubernetes. So for example, like Gang of Four stuff. If you are interested in this and you want to get kind of a common base knowledge and a vocabulary for working with distributed systems, this is a very good book. I do recommend that you get it. Okay, next one we're going to talk about is replication controllers and replica sets. A replica set is basically the next generation of replication controller. They are going to define your desired state of a group of pods. So they're then going to drive that state to the controller manager. So what that means is if you're requesting to have 10 pods and you only have 2, this replication is going to go ahead and try and make that happen for you. So depending on space resources, other constraints, it's going to try its best to give you those 10 pods if you're requesting 10 pods. As a quick overview, let's take a look at how a replica set is going to work. So for example, we're running a replica set and we request to have 12 of these pods running. So the little servers are representing 3 different nodes, and then we have our 12 pods, 4 running in each one of those nodes. So let's say something happened, tripped over the power cord, killed one of my nodes. Well, now I'm only at 8. So the replica set is going to take a look and say, do I have room to spin up those 4 missing pods? Well, lucky enough, my other nodes are large enough and I do have enough room that it can go ahead and spin them up in the 2 existing nodes. So we're back at our happy state of 12. Deployments. These are kind of above a replica set. They are going to control a replica set for you, and they can create and update replica sets. So if you create a deployment, it's going to go and create a replica set, which is going to in turn go and create your pods. One of the advantages of a deployment over a replica set is it does give you rolling updates and it does make scaling a bit easier. So as an example, we'll take a look at how a rolling upgrade could work. So you do have 2 options. You can do an all-at-once upgrade, or you can do a rolling upgrade. So all at once obviously would just kill all of your services and start up your new service as a V2. So in this example, we're going to look at these pods as our V1s, and we got 4 V1s running. Let's say we want to do a rolling upgrade with, we want to do 2 at a time. So we can spin up V2. and we have now 2 pods of V2 running and 4 pods of V1 running. So say we bring it up, we can do some canary testing, a little bit A/B, whatever you want. And we determined that V2 is good enough. We're going to do 50% traffic split at this point. So half our traffic is hitting V1, half of it's hitting V2. Well, looks like V2 is solid. Let's go ahead and turn it all up, and we're just going to send all traffic to V2. And we're going through V2, everything's looking good, but we hit a major bug, and now we need to revert. We can instantly convert all of them back to V1. So it will kill all of your V2s and restart it back at V1. Okay, a service, excuse me. So you can set up a DNS entry that can be used to grant access to a set of pods. It is a DNS entry, but something of note is it doesn't guarantee that it's external. Sometimes services are seen as being an external access to your pods, but that's not necessarily true. It depends on the type of service. So it does allow you to have a consistent endpoint for the pods though. So the different types, node port is going to give you a IP address and port on that particular node. A cluster IP is going to expose the IP in the cluster. An exposed cluster IP is not external though. An exposed node port can be external depending on how your network is set up. The other option is going through a load balancer. This would be layer 4 TCP, works with different cloud providers to create a public IP address for your app. So most likely if you're wanting to expose stuff to the internet, you're probably going to go through load balancing or Ingress, which we'll talk about in a little bit. This is just a basic example of a service. So say we have our deployment running, we have it running across 3 different nodes, we have 12 different pods running, and we set up a service, and that service is actually going to have its own IP address. So as a user from the internet, you could hit that IP address, the service would pick it up, and then go ahead and load balance it. This is missing additional arrows, but adding more arrows I think would make it a little bit more clustered. So potentially a service would load balance across all of the different pods going through there. So let's take a look at our config maps. A config map is just arbitrary values and files. It allows you key value pairs, and you can store different configuration for different pods, for example, different environments. So if you want a test environment, a prod environment, a dev environment, you can store those different configurations in these config maps. And then when your pods come up, they can pull that information through either a volume mount, perhaps local storage, or environment variables. And if you take a look at this, we have 3 different config maps that relate to our 3 different pods that we saw earlier. Now, inside the pods, you're still running Nginx and Redis, but because of the data that you're passing in, you could change the behavior of it. So for example, in dev, maybe your Nginx doesn't support HTTP, whereas when you're running Nginx in prod, it supports HTTPS. So just different options and different ways to pass in configuration without having to actually go and change the pod itself. You can just change the data that's getting passed into it. So next one, Ingress. This is the most common use case for getting traffic from the internet into your cluster, assuming you're not using like some big load balancers like a big IP or something. It basically just defines how you want to get traffic into your cluster through HTTP or a host in a path. We use a default ingress controller of Nginx. There are a bunch of other ones, obviously. So HA proxy, AWS, F5 big IPs. There's multiple options to do the ingress. But the idea behind the ingress is to get traffic in and you control how it works. So we can take a quick look at how that works. So if you hit either one of those HTTPS addresses, it would potentially get picked up by our ingress controller. And again, in our case, we use a default one of Nginx. Nginx would pick up that traffic and decide where it needs to get routed. So this one, it would get picked up, passed to our service, and our service would pack it across to our pods. So this one is, again, missing more arrows, but I think it deals with the point well enough. Okay, so Rancher 2.0 101. These are the different pieces we're going to go through. So setting up Rancher, clusters, auth, storage projects, namespaces, catalogs, and then we'll finish off with some CLI pieces. Okay, I think this is a good time to stop for questions.
Dan, there's just one question right now, and it's could be covered later, but we might as well get to it. It's from Daya, and he asks if Rancher works with Spinnaker. Kind of a CI/CD question.
I'm going to say hesitantly yes. I feel like it's familiar, but I may have to get back to you on that.
Cool. Yeah, cool. Yeah, we can, Daya, you can ask more questions. He says, does Rancher support canary deployments, or do I have to use a Spinnaker-like tool?
Oh, gotcha, like A/B testing, those kinds of things.
Mm-hmm.
Yeah, so that was kind of what we talked about before with using the deployment. So you can set up workloads to do some canary testing. So Rancher itself is not going to set up, like, for example, splitting the traffic between two different workloads. But we do have apps or catalog apps, which I'll show later, that you can pull in to use some of that stuff. Or as you mentioned, you can work with things like Spinnaker.
Awesome, thank you. Yeah, that's it for now, so you can keep going.
Okay, cool. Demo time. All right, let's go take a look. So we're going to start up in our docs. Move this little bar here. Okay, so fastest way to get here, hit rancher.com, go to learn, Rancher docs, Rancher 2.x, read the docs, installation, single node. This is the easiest way to get up and running with Rancher. It's just going to spin you up a Docker container that's going to run the Rancher service and allow you to start making clusters. So if we go through, again, feel free to follow along if you're running a Linux box somewhere. We support multiple different operating systems. This is give you a little overview of how much hardware you need to run what. We do have specific supported versions of Docker. If you are not running one of these supported versions, we can't guarantee that it's going to work properly with you. I do use newer versions of Docker without a lot of issues, but again, like if you wanted support or something, you'd have to be running a supported version. So looking at the ports, these are the ports that we're asking to be open or that have to be open in order for us to talk to these different services. So for example, port 22, so we can SSH into different boxes and do provisioning if we need to. We need to be able to talk to the Kubernetes API, just different pieces. So when you're installing Rancher, you have multiple different options for SSL. The easiest option and the route that we're going to take today is to just do a self-signed certificate. You can, as a clarifying note, this will actually create a self-signed cert for you, so you don't need to have your own. Option B, you can bring your own self-signed. You can also use a cert that is signed by a recognized CA, or you can go through Let's Encrypt and get a certificate through Let's Encrypt. So this option is actually pretty cool because it gives you a valid CA cert and it's really fast. So obviously you have to own the domain name that you want to use, but it allows you to do it very quickly. So to do this, it's actually pretty fast. You just need to have a Linux host running with the supported version of Docker and just run this command. That is going to get you a Rancher server up and running. All of our stuff is on Docker Hub. So if you want to run the server or any of the other images that we're using, everything gets pulled out of Docker Hub. We do open WebSockets to communicate through to our clusters. And we obviously need access to 443 so that we can talk through the management plane. So some of the only exceptions to these is cloud hosted, like GKE, AKA, EKS. We also require 6443 inbound so that we can actually talk to the management plane. So for example, in GKE, you don't actually own the management of the cluster. You're essentially just running nodes in there. So we need to be able to have access to talk to the management side of it in order to provision and move things around. If you're doing an IaaS, you want port 22 so that we can SSH in, install Docker and Kubernetes. So if you're just running a bare metal and you want us to spin it up, we have to have port 22 open. So we're going to go ahead and spin this up and we'll take a look. So for the demo, I've already run the command just so you don't have to watch it building. And this is just running on a DigitalOcean droplet. I can jump onto that one. So this guy, nope, I don't actually have it up on my CLI right now. But basically, if you just run a Docker PS, all it's going to show you is that there's a single process running with just Rancher. I currently set it on 8443 instead of 443 just because I run a lot of testing. So when you first log into Rancher using a self-signed cert, it is going to ask you to validate it because it is a self-signed cert. So your web browser will probably yell at you, tell you it's invalid. You can go ahead and accept it, add an exception. And when you first start Rancher, it's also going to ask you for a URL. This is based off of the URL that you use to get to the login screen for the first time. So for example, I'll be able to show you in the settings in just a moment, but this right here would be my Rancher URL. So if you are trying to run this and connect to clusters out on the internet, you can't use localhost because we won't be able to health check against localhost on clusters that are not local. So you can use something to give you an external one. So let's go and log in and we'll start taking a look. I have already set up Rancher with GitHub as my login auth provider. You can use local, which is what it will ask you to do when you first set up Rancher. So I'm going to use GitHub so that I can show you some of the cool features that come along with that. So this is just our main screen. We are going to run through 3 different levels in the hierarchy. So the first one is called global. Second layer is our cluster. Third is going to be project. So again, let's take a quick look at settings. And if we go and look, you can see that this is what my server URL is set at. Again, if this is set as a local host, you're going to have a hard time trying to spin up clusters outside of running them locally. So let's go back to global. So the first thing we're going to take a look at is auth. So as I mentioned, I'm currently running GitHub as my auth provider. So that makes it really easy to set up your app with GitHub. You just grab the secret keys, authorize it on GitHub, and you're good to go. So the interesting thing about this is I can add users to my Rancher cluster, and it will pull from any user that is in GitHub. So if I just start typing in here, it's going to give me a list of everybody that starts matching the name of that particular user. I'll go a little bit more into the auth pieces at a later point. To give you an idea, these are the current providers that we support. We are open to adding additional ones depending on what people request and the need for them. So like, for example, when we first started, we only had 1, then we had 2, 3, and then we added the last 4 very recently. So do we have any questions at this point?
Yeah, there are a couple. So the first is from TJ, and he asks, is there a best practice for etcd isolation between the Rancher etcd and Kubernetes etcd?
That's a good question. So to clarify, Rancher is actually using etcd. So when you are spinning up so right now, Rancher is actually running etcd itself, and it's running a single node cluster automatically when you spin it up through this way. If you are doing this in more of a production environment, So for example, you install Kubernetes yourself and then you ran Rancher in that Kubernetes instance. Rancher hooks into that etcd, and that etcd is the same etcd that we use. So there's no separate data stores, there's no separate MySQL storage or anything like that. We use the etcd that is part of that Kubernetes cluster.
Awesome. Okay, great. There's a couple more, Dan.
Okay.
Marcus asks, will Rancher renew the Let's Encrypt certificate if I choose that route?
To be honest, I don't know if we do the auto renewal. That is a good question, and I would have to check on that. You can throw that in the user Slack, and I'm sure somebody could answer that much quicker than me trying to find it. Other option is we can check the docs, but I don't actually know offhand.
Okay, no worries. That is why we have additional resources. Good question, Marcus. Okay, this last one is from Nathan. He says, if the initial Rancher server URL is set to the IP of one node in a Kubernetes cluster with multiple nodes running etcd, will the Rancher UI survive the failure of that initial node?
So we only hook into one etcd, right? So, and when you're talking about the management of Kubernetes, you are probably going to only be running in a single place. If you have a failover etcd, that's kind of a different situation. So Rancher is going to come up on your host, and it's going to communicate with whatever etcd it's supposed to be talking to at that point. If you run it through the Docker command, it's going to spin up that etcd for you. If you are already running Kubernetes, then it's going to get ran in your Kubernetes cluster and talk to whatever the master thinks is its etcd. So if you're running etcd on other nodes, then in general, Kubernetes is going to have a hard time talking to those anyways, unless you're talking about like some failover situation where maybe you have some DNS. If one goes down, your IP is shimming in the new one or something. But mainly, you're only going to be running one etcd, and then whatever you're going to be doing for failover, which is beyond the scope of this.
Rock on, right. Well, so there's a couple other questions around CI/CD and the app catalog, but why don't we wait for those till you get to, Helm and stuff later on in the demo.
Yep, definitely. I will be covering app catalogs and Helm and those stuff just a little bit later. All right, so next thing we're going to talk about is clusters. So right now, I already have one cluster up and running that Rancher created for me. It is just running in DigitalOcean. So what that does is Rancher provisions a droplets. It SSHs into that box, it installs Docker, it installs Kubernetes, and it gets it up and running for me. Once everything is up and running, you can see that it gets pulled into the system. And now I can see that I have this cluster up and running for me. Let's take a look at adding another cluster. So there are quite a few different options. If we look at these top three, these are hosted Kubernetes providers. So GKE, EKS, AKS. In those instances, you would have to provide your access information, and we would go in and provision the cluster for you. In these situations, obviously we don't provision like a host, and we don't have to SSH in. That's why we need the different port access in order to be able to talk to these providers. The second one is through IaaS, so Amazon, Azure, DO. Again, DO is what I'm running because it's just easy to spin up. In these cases, these are the ones where we go in, and if I say I want another DigitalOcean cluster, it's going to go and provision a droplet for me, and it's going to SSH in and set everything up. That was what we saw previously on the cluster screen. So let's go ahead and talk about custom. Custom is a situation where, say you already have a host, it doesn't need to be provisioned. You can just go ahead and put in the name of it, and then you can determine what members you want to add to this cluster. So because we are using GitHub, again, I can just go in and type in a name and find different users. So I can look up Rancher Labs. Rancher Labs is actually a group in GitHub. So if I added Rancher Labs as, say, a member, anybody who is a member of the Rancher Labs group would have access to my cluster as a member. So if anybody watching wanted to log in and they were part of Rancher Labs, they could easily do so. Let's take a look at the options for adding a custom cluster. So we do give you a couple of different options for the version that you can run. Older versions of Rancher support more of these. Like our current release, I think, supports a couple more options. I'm running off of master, so I have less options. So we also offer different network providers. So we have Flannel, Calico, and Canal. So the difference between these are going to be how they're actually set up. Different FDNs. So our default is Canal. It kind of gives you the both worlds, best of both worlds for between Flannel and Calico, because it does give you network policy. So that's the one we actually default to. It's pretty nice. You can switch depending on your network needs, obviously. And then if you take a look, project network isolation goes away if we switch to Flannel, but under Canal, it does give you the option to isolate your stuff a little bit more. So you can turn on and off that Nginx ingress that we talked about. There's also a metric server and pod security policy, which I'll talk about a little bit more about in just a minute. Docker version on your nodes. So you can do two options. We can do unsupported versions. So again, I do run a version that's technically unsupported, but I haven't had any issues. You can go that route, that's fine. You can also say that I require a supported version. So we'll jump on the box, check the version of Docker that you're using. And if you're running a version that we don't support, it will give you a warning and it won't let you continue creating the cluster. So the last little important one is cloud providers. If you select one of these, that kind of helps us set up the host for you. So if you go through, for example, with Azure, we have a bunch of different options that you can set that are specific to Azure. There's a link to go out and look at different cloud providers. Another thing you can do is you can just grab this file and you can edit yourself. So if you already know the different options and different things you want, you can just hit edit as YAML and update it this way, which is pretty easy if you know what you're doing. The other option is we can read it from a file. So for example, say you already have your cluster set up somewhere, you can grab, you can export the cluster config, and then we can just say read from file, pull it in, and then you don't have to do any of this stuff. So I'm going to go ahead and show you import cluster, and I'm going to import a cluster so that we can take a look at how that works. We're just going to give it a name. I'm just going to add me as a member. So notice when you're importing a cluster, there's really no other options. It's just name and who you're going to add to the cluster. That's because importing a cluster means you're going to take a cluster you already have running somewhere else, and you're going to pull it into Rancher and allow Rancher to essentially look at that cluster and perform some operations on it. There are limitations with an imported cluster, and I'll show you those in just a moment. So it gives you 3 different options for how to run the command to import the cluster. All 3 of them are going to do the same thing, but because we're running a self-signed cert, we need to grab the last one. Otherwise, we won't be able to actually pull the cert without getting errors. So we're going to go ahead and hit done on this, and we're going to take a look here. So I still have my original DigitalOcean cluster. That one's still up and running. Everything's fine. And now I have one called pending, and that's called import, and my provider is now imported. So what this means is we told Rancher, hey, we are planning on importing a cluster, but at this point, we haven't actually done anything in the cluster, so Rancher doesn't know about it. It doesn't know what it's doing. So if we flip over here, this is my cluster. So if we take a look, this is just a typical cluster. This one was spun up using RKE. That's a Rancher tool that we have that makes it super simple to spin up clusters on hosts. And it has nothing to do with Rancher at this point. It is just a Kubernetes cluster. So what I'm going to do is I'm going to run this command. And when you run this, you can see the different things that get created when you run it. So it gives you a new namespace called cattle system. any cluster that Rancher is a part of is going to have a namespace called cattle system. It's also going to set up a service account, role binding, some secrets, deployments, statement sets, just different pieces that Rancher needs to run in there. So the main thing that we can look at is we now have that cattle system. And if we take a look, you can see that we're now running this cluster agent. The cluster agent and the node agent are actually what talk to Rancher. Earlier, I mentioned that we open up a WebSocket. These are the guys that open up the WebSocket into Rancher and allow that two-way communication. So we do use WebSockets because that makes it easier. We don't have to keep opening and closing connections. We just have a WebSocket. We can use that, talk back and forth. It makes things a little bit simpler. So let's jump back to our UI. And now you can see that our cluster is active. It shows us our CPU, it shows us our RAM usage, and just general information about the cluster itself. Do we have any questions at this point?
Yes, sir. Let's see. There's a couple questions about network provider.
Okay.
Nicholas asks, he literally says, Dan, what do you prefer to use as a network provider at the moment?
I just use the default canal. It's going to give you, like I said, kind of the best of both worlds of Flannel and Calico. So it does give you access to network policies as well. So it's a good middle ground, and it's also going to give you safety if you need to run network policies, which, like if you're doing multi-tenancy, you pretty much want to run that.
Okay, cool. And so this is another kind of follow-up question from Daya again. Does Rancher internally use or recommend any service mesh? Is there a best combination of network provider and service mesh?
Service mesh. I was curious if someone's going to ask about that. So for service mesh, we don't actually do anything yet. If you have or haven't heard, we have another project we're working on called Rio, where Rio does do work with service meshes. As of right now, we're not doing anything with that directly in Rancher. So yeah, if you have a service mesh that you like to use, feel free. Rancher doesn't get in the way of any of that stuff, right? So if you just set up a network provider and you have a service mesh that you want to use, so say you want to roll out Istio, there's no problems with rolling out Istio. So Rancher doesn't get in the way of anything, and we're not really opinionated about some of that stuff. So you can do whatever you want as far as the service providers, or sorry, the service mesh.
Cool. And actually, on that note, we did just post a blog on using and deploying Istio with Rancher, so I might send you that link, Daya. Okay, cool. There's one more. I can't remember if we actually got this already. It's from TJ. Is there a best practice for etcd isolation between the Rancher etcd and Kubernetes etcd?
Yeah, we talked about that one.
Okay, cool. Thought so. Yeah. All right, that's everything so far. So keep going.
Okay, awesome. So we're going to jump into cluster level features. Again, as I said at the beginning, we're at 3 levels. So we're global, cluster, and project level. So let's go into a cluster and let's take a look. So I'm going to go into my DigitalOcean. It's going to give you a nice little overview of what this particular cluster is doing. So I have a little health checks, I have usage, what version we're currently running, who my provider is. To clarify on provider, it is actually using Docker machine to provision this. So it does give you information as to how we're actually running that particular cluster. So in this case, I am using Docker machine on DigitalOcean. I currently have 1 node when it was created and just some general information. One of the really cool features about the UI is this thing. It's called launch kubectl. If you're at all familiar with Kubernetes, kubectl is the command line to use when you're interacting with your Kubernetes cluster. When you start running multiple clusters, then you start running into issues with dealing with context. Context is essentially what cluster you're looking at, what cluster and namespace you're looking at. The nice thing about this is you are automatically in the correct cluster when you use this button. So the way that works is we actually go and talk to the cluster, we pull your kubeconfig, and we open a shell directly into that cluster for you. So it's essentially like running it directly for your cluster on your local machine, but you don't have to worry about context. You don't have to worry about downloading the kubeconfig certs and all that fun stuff. One more thing is you can grab the kubeconfig file. So if you prefer to run locally, so for example, I do run kubectl locally. It was connected to my local machine last, so it's actually broken. Well, if I wanted to, I could go grab my kubeconfig file and actually copy that and pull it in to my kubeconfig, and I could run it locally. So you can download the kubeconfig for your cluster and use it locally if you don't want to use it through this UI kubeconfig version or this kubectl version. So this is just cluster level. Let's go take a look at nodes. So something to note is depending on how you created your cluster, if it was imported or if it was custom or if it was created through one of the IaaS providers, it changes what you can do with the nodes in the cluster. So because this cluster was created through Rancher, I can scale it. So if I just push that up, that's actually going to go out to DO. It's going to provision me 2 additional droplets, and it's going to set up 2 additional nodes for me inside of my cluster. To show you the difference, if I go back to my imported cluster and look at nodes, I don't have that option. Because that cluster was imported, Rancher doesn't have control over it, and it can't actually go through and create additional nodes. So for an imported cluster, if you want additional nodes, you would have to go through and provision them however you provision them initially. So let's go take a look at this guy again. So you can see that these are still provisioning. It takes a minute or two. It doesn't take very long, honestly, to add additional nodes. Once they're up and running, it's going to SSH in, it's going to install Docker, it's going to install Kubernetes, and it's basically just going to get it working for you as part of your managed cluster. So, yep, you can see that it's currently working through the different processes. And once they come up, we'll be able to see them on the main cluster screen. So down here, you can see that our nodes are unhealthy because they're still actually provisioning. But once those come up, this will all go green. And you can see that these graphs kind of change because it's going to give you kind of a general overview of where the different nodes are at. So next one we're going to jump into is storage. Trying to do storage through Kubernetes can be a little complex. They give you a lot of options. They give you a lot of different knobs to do. With this, we try to make it very simple. So you can come in. Well, let's switch clusters while this one is updating. So we're going to go to my imported cluster. With the imported cluster, you can still do any of the other things that we provide outside of nodes. So in here, we can still go in, we can still add volumes. So you can just call it whatever you want, and you can choose a volume plugin. So this is kind of where your storage is coming from. If you are running something in Google, you probably don't want to try to use Amazon. Sometimes there are issues doing cross-cloud storage. But overall, just kind of use whatever you're used to. You can do local disk if you know that you're having a bunch of storage on your host. The plugins these are all available outside of Rancher. We just take advantage of them. So you can just select whichever one you want. So if you picked Amazon, it's going to give you different options. So file system, partitions, again, you can customize it a little bit. These are kind of typical options when you're adding storage to Kubernetes. We just make it a little bit easier to do it for you. The other option is a storage class. This gives you categories of storage, which is a little bit different than the volumes. So again, kind of pick it based on what cloud provider you're using, or if you know it's going to work somewhere for you. So if we pick Amazon, it allows you to pick what kind of storage you want. So for example, you can do SSDs, which are obviously faster. Maybe you're doing some long-term storage, you can pick the cold storage option. And you can pick your zones, encryption, and then again, it has a little bit of extra customization. So some of these options do change as you click through the different providers. So this is information we're pulling from the providers to allow you to customize what kind of stuff you're wanting to use. So for example, Google, they only have 2 types and then just a couple of different options. So let's move on to project and namespaces. Now, this is a Rancher construct. A project is not actually a thing in Kubernetes. It is something that we created, and we use a CRD, or a custom resource definition, to keep track of these. So a CRD allows you to create a resource in Kubernetes that Kubernetes will keep track of for you, but you are able to create it. So in Kubernetes, every cluster has a namespace. So what we do for a project is we group these namespaces together into a project. So for example, you could have a dev project that holds a namespace for each one of your devs. If you only have 3 devs, they each get their own namespace. They can only do stuff within that particular namespace. So it gives you a lot of control. It gives you a lot of access control, and it allows you to create cool and different things, and keep things separated if they need to be separated, put things together if they need to be put together. It is a one-to-many relationship, so a namespace can only live to one project. Obviously, a project can have multiple namespaces. So when you first spin up a cluster, you are going to get 2 default projects. So you're going to get one called default, which always houses your default namespace. Kubernetes always has a namespace called default. There's not much you can do about that. There's also one called system. This is one we create, and this one just houses the different namespaces that are related to system processes. You probably don't want to put anything in here unless you know you need to, but like kube public, kube system, these are 2 you don't really want to touch. Ingress and Nginx. This is where our ingress lives. It's not technically ours, but for example, if you don't want to use the Nginx ingress, if you delete this namespace, it will delete the Nginx ingress controller, and then you can use whatever ingress you want. Cattle system is the namespace that I showed you earlier, where we run our agent and whatever else we need to add in there. So if we take a look, something to note though is you can delete any of these namespaces, right? So for example, if you import a cluster, and right now we are in my import cluster, if you delete the cattle system namespace, that essentially takes Rancher out of your cluster for you. So if you import a cluster, you decide the Rancher is not the thing for you, or you want to go a different route with creating your cluster, like you want Rancher to have full control, you could delete the cattle system namespace. That will kill the agent, and then we would no longer have communication with your cluster. To note though that we do add annotations and labels to different objects, so stuff like that would still live, but that doesn't have any implications for your cluster. They're just metadata on top of your objects. So we can create a new project. So let's go ahead and do that. And we're just going to call it demo. And here's the interesting part where we can add people and give them different accesses. So this is similar to the cluster. So if I look up Rancher Labs, I can pick how I want this person to be. Let's say I want them read-only. That person is only going to be able to read anything in my project. So let's go ahead and create it. I now have a project called demo, but it doesn't have any namespaces. A project doesn't really do much unless you actually have a namespace in it. So let's go ahead and add a namespace. We'll call it demo2. Because we created it off that project, it automatically thinks that we want it associated. You can throw this namespace anywhere you want, but for our purposes, we want it as part of the namespace. Okay, cool. So we have a new project called demo with a new namespace called demo2. So what I'm going to do is I'm going to jump back to kubectl and show you the namespaces. You can see that we just created a new namespace in that imported cluster. So we're not doing anything magic here. We're just creating namespaces, standard Kubernetes objects. We just group them together for you as part of this project. So that allows you to have easier control with your RBAC, allowing different people to have access in different ways. So another thing you can do with the project, hang on. When we're doing our projects, we have the namespaces. So let's just continue on. This is an overview of our cluster members. And this was similar to what I showed earlier, where it allows you to add members when you create the cluster. You can also do it once the cluster is already up. So again, we can do Rancher Labs. This is pulling from all of GitHub. So it is hitting GitHub and pulling all the different users. So we can also do a custom user, and you can pick different individual roles, depending on what kind of roles you want. I will go a little bit further into these options in just a little bit, and we talk a little bit about the security. So let's go back to the top level. Let's go check out that other cluster that we were waiting for. If we go look at our DigitalOcean one, we're going to go look at our nodes. So it looks like we're having issues with our network. So it is talking to the cluster, but something's wrong with the cluster. So we're just going to pretend like that worked, and we're going to continue on. So we do have some additional tools here, alerts, notifiers, logging, pipeline. We're not going to talk too much about those. I think that some of you guys were asking about some of the stuff like pipeline with CI/CD. So this would be kind of the area that you'd want to look into for that. Again, with our docs, we have pretty good docs, so you could check those out as well. We're going to go take a quick look at, actually, let's go up a level. We're going to go back to global. So we're going to go ahead and talk about catalogs. I know that someone asked about those, so let's jump in and look at them. Catalogs. So there's two layers to a catalog. You have the catalog itself, which is pulling in the information. For example, we have our library and our Helm catalogs. Library is a list of curated catalogs or Helm catalogs that we have gone through and actually made them a lot easier to use, and they should just work out of the box. If you want, you could use Helm, which is essentially like a Docker hub for Kubernetes. A catalog gives you access to apps, which are basically just YAML files that tell Kubernetes how to launch this application. You know, what services do I need? What pods am I going to be running? What's connected to what? So we default to just using library. You can enable Helm Stable or Helm Incubator. You also have the option of adding your own custom catalog. So say you're doing an air gap install or something, you don't want to use any of those. You want your own safe curated list of apps that you only trust internally. You can go ahead and add them here. Give it a name, give it a URL. We only support Helm catalogs at this point, so it would have to be a normal Helm catalog in order for us to be able to use it. So right now I'm just going to leave library enabled. If we turn on Helm Stable, it's going to download all the different apps and show those to you in the app screen, Helm Incubator. So again, with library, this is stuff that we have actually taken from Helm and just made sure that it's going to work with Rancher out of the box. Some of these apps, when you try to use them, they don't work out of the box all the time, and so it can be a little harder to use them. So we don't really make any changes. We just make like same defaults that work with Rancher. So let's go back to our imported cluster. We're going to jump back to projects, and we're going to go into our demo project. So what we can do in here is go to catalog apps. And right now I don't have anything. So let's go ahead and launch an app. So at the top, it's going to give you some different categories and some different catalogs. Right now I only have library enabled, so it only shows things from library. So there's quite a few options that you have with just running the library. If you turn on Helm Stable or Helm, the other Helm, you get a lot more options. So let's just go into a common one. Let's go take a look at Grafana. It's going to give you a detailed description of what the different options are, how those options work, and what you can set. So for us, we're going to leave it with the name of Grafana, and you can choose what version you want to run. When you're picking out of the library that we support, we usually only have 1 or 2 versions. But if you're using like Helm stable, there could be 10, 20 versions depending on what different app you're looking at. Something to note is it is going to create a new namespace for you for this particular app. So we do that for segregation, make sure that it's safe and it's not going to trample over other things. You can customize where you want it to go. By default, it just takes the app name and makes a namespace for it. A couple different options with actually getting the app to run. Again, you have an edit YAML option, and these are what we call our answers file. So it's saying, do you want the default image, what image repository, tag, and so on. You can also read from file. So same thing we did with the clusters. These are the same questions that are in that YAML file, just in a nice UI setting. So we're just going to go ahead and give it the password and look at these different options. Then the other thing we can do is take a look at the different YAML files that actually build up this Helm chart. So answers.yaml is the one that I just showed. When you edit your YAML, this is essentially what you're answering. So what we do is we take these questions or these answers and we put them into these other files where they actually need to go. So some of these other files have templates and we'll go ahead and just put information in. But you can see that it takes a lot of different YAML files to make up some of these applications. So we're just going to leave everything as default. We're going to hit launch, and then we're going to take a look at what it does. So while that's loading, I'll just go through some of the other menus real quick. These are some of the different options that you can set up. So alerts, which are pretty cool. It allows you to set up alerts on different things. So you can have like different webhooks. If you have space constraints, things like that. Logging, registries, secrets. Secrets is just standard Kubernetes secrets. Namespaces, this is the same piece that we just saw. So now you can see that I do have a new namespace called Grafana, and that one is up and running. Again, members tab. So you can see that we do pull in the pictures for these different groups. So Rancher Labs is considered a member of this, and they are read-only. So now that we have our catalog up and running, let's go take a look at the workload screen, which we haven't seen yet. And you can see that we now have in our namespace, we have one pod running. So this tells you what exactly it is. So if we go look at this, this is our workload, and it gives you information as to what this is actually doing. It's currently just running a single pod that's using 2 images. So it gives you a bunch of information about it. These are all different things that you can look at. You can edit. So if you know that you need to update some of this stuff, for example, you know your health checks don't work on this port, you can change it. Just a bunch of different information about that particular deployment. So if we go back to catalog apps, you'll notice that there is a IP or a port and a TCP here. So if we click on this, we are at the Grafana homepage. So one of the cool things that Rancher does is if your application has any kind of public exposure, we do try to infer that and give you a way to click on it. So another thing that you can note is we will build you a zip IO depending on what you're deploying. So that was an option in the Rancher settings. So you can see that this is technically exposed to the internet right now. So if you guys hit this, you would actually be able to see that Grafana dashboard. Some of the cool things you can do with apps, you can do upgrades or rollbacks. Because you're using the library, you can't actually do that because there was only one version. But if you had multiple versions of it, you could do upgrades or rollbacks. And then you can also just go ahead and delete it. And so no more apps. If we go look at our workloads, workloads are empty, namespaces, we just still have the Grafana namespace. So we don't clean up the Grafana namespace because there is potential that you are having other things running in it. We don't want to kill namespaces unless you explicitly delete them. So in my situation, I know that I don't want it anymore. I'm going to go ahead and just hit delete on it. So any questions at this point before I jump into the CLI pieces?
Let's see. Stefan has been waiting patiently, asked, Regarding CI/CD integration, does Rancher integrate with drone.io? Maybe drone.io call the Rancher CLI.
So we do use drone. We actually use drone internally as well. But for pipelines, um, we do use drone. I'd have to check the docs to show. Let's just go jump on the docs and take a look real quick. Whoops. I know that we do have a bunch of support for stuff. I don't know off the top of my head what all we support. What? So this is basically where I'd be looking. Apparently our searching is not working very well. This is also showing done. But yeah, we support quite a few different pipelines. So again, you'd have to kind of look into it at the docs as for the pipelines and CI/CD pieces to figure out what all we support, or you can jump into the user Slack and we can look at it that way. But again, off the top of my head, I don't know everything that we support because we do add stuff pretty quickly.
Cool. Okay, great. Well, there's a couple more. Nicholas asks, he says, since storage is a pain, at least for me, with what solution could I easily start?
I think that is a very general question, and you'd probably need more context. So depending on what you're trying to do, I mean, for the example that I showed, we were running like Nginx with Redis. So, I mean, if you're running on a host that you own, you could just mount in a volume. That's honestly the easiest thing to do, right? Is just get a volume mounted in. If you're using AWS, you could probably just pull in some AWS storage. But yeah, I mean, it depends on your use case. If you would need more specifics, you can jump into the user Slack, and a lot of people could provide probably more information as to what would work best for you.
Okay, cool. Jeff asks, thank you, Dan. Jeff asks, how are rights handled if I have users who are members of multiple groups?
How are rights handled if I have users who are members of multiple groups? I'm not sure what you mean by rights. If you're saying access to like a cluster and we have different members. So for example, if we look at this cluster and we add a member, I see what you're saying by rights. Like we go off of whatever, I believe we go off of the highest access level. So if you're part of two groups and group A has admin access and group B does not, we're going to use group A because that's the highest level of access that you have. Does that hopefully that answer the question?
Yeah, Jeff, if you have more clarification or want to give some more context, please do. Oh, he says yep. So that was good.
Okay. Yep.
Cool. Let's do one more and then you can keep going. Dia says, does Rancher have built-in monitoring and alert system, or do I have to use Helm library for that? If yes, then which one is recommended?
Sure. We do have alerts. So these are the current, we have alerts right now that are just kind of just built-in ones. So like we have an alert for etcd. If we go and look at it, it'll kind of show you what it is. So system service etcd. And if it's unhealthy, it'll send a critical warning. And we can change where it's actually going to. Right now, this doesn't actually have any. So there is no alert set up right now. So if we wanted to create one, we can call it demo. Let's say these are the different things that you can look at. So let's say we want a controller manager, or we can also go with different resources, a particular node selectors. So let's say we want to look at this node and we can say that CPU use is over 70%. We could send a warning and we don't have any notifiers set up. So we would actually have to go and set up a notifier. So they're kind of two different things, right? You have alerts and then you have notifiers. A notifier is where the alert is going to go to. So if I add a notifier, I can do Slack, email, pager, webhook, whatever you have. So we just call this demo. This just goes to demo.com or whatever. You could add that. And when we went back to our alert, even editing one of these, you could then use that notifier here. And whenever this situation came up, basically, it would alert back to there. So that also goes back to kind of the question about logging. So we do support multiple logging. and different pipeline pieces. So I guess I can enable it without, yeah, anyways. So one thing I did want to talk about is pod security policies. A pod security policy is actually a Kubernetes construct, and you can set up different policies. And this is going to change the way that your pods run in your cluster. So this is going to change how much, like escalation privileges they have. It's going to change what they can do, who they can communicate with, a bunch of different options. So you get lots of different knobs you can tweak in here. So different volume policies, all of this fun stuff. So pod security policies, again, are a created construct. It's not something that we created. So it's going to allow you to give a lot of safety to your cluster. So for example, if you wanted to change how a pod has access to other pods, you can use pod security policies. When you're looking at these, we do have two default ones. So restricted, you can come in and see these are the different options that a restricted one has. So we don't allow any of this stuff. And you can go through and just kind of look at them. Unrestricted, maybe you're doing some testing locally and you want it to be able to escalate, sure. Then go ahead, it can do a host PID, sure. It can use the host network, sure. These are, again, another thing on top of RBAC that's going to help you keep your cluster safe. If you are starting to run stuff or considering production, you definitely want to try and look at pod security policies to make sure that people can't essentially break out. Okay, so let's go ahead and move on to the CLI. And the CLI is a very cool tool. I say that because I wrote it. So you can go down here and you can download whatever version you need. For me, I run the Mac version, obviously. And something to note with Rancher is we don't get in the way of Kubernetes itself. So even though we have a CLI, it still allows you to use normal Kubernetes things. You can still go through this way that we talked about earlier with launching kubectl and doing it this way. But with the Rancher CLI, it does give you access to some of our constructs like projects. So right now, I'm not actually connected to anything, right? So I was connected to something else that is not the current cluster that I'm running or the current Rancher server. So what I need to do is go and create an API key. So I'm going to go ahead and create a new key. It's going to expire whenever I want. You can give it a description. I'm going to create it, and I'm going to go ahead and log in. So I'm going to type Rancher login. I'm going to give it my token, and then I'm going to go ahead and give it my URL of my server. So what that's going to do is it's going to connect to my Rancher server, and similar to when you SSH into a box, because we're using an unsigned cert, it's going to ask you to verify it. If you think that, yeah, that's the cert that I have, you can go ahead and hit yes. And it's going to ask you what project you want to set as your current context. So similar to the kubectl, we do have the idea of a context, which is the cluster and project that you're currently looking at. So when you run commands against the Rancher command line, it is going to be using that context unless you tell it explicitly not to. So for us, let's go ahead and just look at 3, which is my imported cluster with our project name of demo. So now if I run Rancher PS, I actually don't have anything running right now, so I don't see anything, but I could run Rancher nodes, and it's going to tell me that I currently have a node up and running on there. So another cool thing is we allow pass-through directly to kubectl. So when you run Rancher kubectl, it's going to operate very similar to the way that launch kubectl does. It's going to automatically go and grab the kube config for that particular cluster, and it's going to use it to run the command that you gave it. So if I want to switch my context, I can go ahead and run Rancher context switch and say I want to go back to number 2, which is a different cluster. I can run the same command. It's going to get the namespaces. And you can see that this guy has demo 2 because I was looking at my imported cluster. Now I'm looking at my DigitalOcean cluster, which does not have the namespace. So when you're running Rancher kubectl, it is full kubectl. We are not hiding anything. We are literally running kubectl in that cluster for you. So anything that you can do through kubectl, you can run through Rancher kubectl. It just makes it easier, and you don't have to switch the context or download the kubeconfigs or any of that fun stuff. So, for example, with workloads, when you are doing workloads, you don't do that through the standard Rancher CLI. You would do that through the kubectl piece of it. So anything that is part of kubectl, we don't try to take over with the Rancher kubectl. But anything that is a Rancher construct, you can use through here. So for example, in this cluster, I have 2 projects. Okay, that's about all I have. If anyone has any more questions, happy to answer them.
Awesome, thanks, Dan. Thank you so much for going through all of that. There's a lot to cover, so well done. And there are a couple questions.
Yep.
Daya asks, is FluentD an option in Rancher for centralized logging?
Is FluentD an option for logging? These are our current options for logging. I know there's been chat about FluentD, but I couldn't tell you any more than that. I don't work on a lot of the logging stuff.
Cool. And then, Daya, you might know that, or might want to know that the Rancher wiki on GitHub does put some timelines for different editions, so you might want to check there too. I can include that. Yeah, that link in the follow-up email. Okay, next question. This one is the last that is here. It's from Nicholas. He says, are there any possible reasons that ingress to xip.io might not work?
Are there any possible reasons? Yes, zip.io goes down. Previous experience, zip.io is a little bit flaky. So if you have an ingress that's using zip.io, it's possibly that it's being flaky. If you are saying that it's consistently not working, then it would probably require more troubleshooting, and I wouldn't be able to just tell you why. But ideally, it should kind of work out of the box. I mean, a good test would be maybe just spin up like the Grafana app that I used, and then it's basically default settings that Kubernetes or that we know work. And as you saw, it just worked for me. So if it doesn't just work, there's probably something else going on. So maybe network access, you have a firewall somewhere, like who knows?
Awesome. Right. Okay, cool. Okay, well, that's all the questions. So I think we're good. I'm just gonna take control of the presentation again just to show these last resource slides, Dan.
Okay.
So let me switch over and show my screen. Can you see this Slack slide?
Yes.
Okay, sweet. So yeah, just a reminder to everyone, this, you slack.rancher.io. You can ask a lot more questions there. And again, this whole session has been recorded. So we will send out the video recording and the slides and the Q&A too. So that's all we've got. Again, Dan, well done. Thanks a lot for being here. And I hope everybody has a great rest of the week. All right, talk to y'all later.